Hello students, Karnataka Law Society's Vishwanath Deshpande Institute of Technology Hadiyar, Department of CSE welcomes you to the lecture series on software engineering. The subject name is software engineering and subject code is 18 CS35, module number 3, lecture number 22. Myself Salim Hebbar from the Department of Computer Science and Engineering. Topics covered in the previous class are object-oriented design using UML. So in that we studied system context and interactions, architectural design, object class identification, design models, and interface specification. System context and interactions is to set up the context for the system. We had taken the example of weather station and its associated system to which it is going to interact and get the information. So, weather station system and its associated systems, those will be forming the context or the environment of the system. So, try to gather the information from these interactions between the system and the other systems connected to this. Then go for the architectural design. So where you need to form a design of the entire system which depicts the architecture of the system, such as you may be having a communication link and you may be having a subsystems such as say fault manager or fault subsystem. Then you may be having a data collection system, then a communication system, and then instrument system subsystem. So that way you may be having some set of subsystems such as another a configuration management system or configuration systems. So all these will be forming the subsystems, in fact the system which will be representing the architectural design of the system. So in connection with the object-oriented design using UML, you need to identify the object classes. So with reference to the context of a weather station and its a related subsystem, you need to identify some set of the objects or object classes. So we identified at least 5 object classes such as ground thermometer and anemometer, barometer, then weather station and weather data. So this way we identified 5 different objects along with their attributes and operations. Then go for the design model. You may go for the static model or the structural model or the dynamic model. In the dynamic model, you may be having the sequence model or the state models. So sequence model will be represented with the interactions that are taking place between the components in the weather systems, and the state model represents the state of the system at one particular moment of time and their transitions from one state to another state. Then interface specification, that is used to specify the interfaces. Specify interfaces between the components or component parts. Topics to be covered in today's class are the design patterns and what is the learning outcome. At the end of this lecture, the student will have better understanding of design patterns. Let's take up the design patterns. Design patterns were derived from ideas put forward by Christopher Alexander, who suggested that there were certain common patterns of building design that were inherently pleasing and effective. Pattern is a description of the problem and the essence of its solution so that solution may be reused in different settings. Pattern is not a detailed specification. Rather, you can think of it as a description of accumulated wisdom and experience, a well-tried solution to a common problem. Patterns have made a huge impact on object-oriented software design. Published patterns often rely on object characteristics such as inheritance and polymorphism to provide generality. One can have configuration patterns for COD system, commercial off-the-shelf system. Patterns are a way of reusing the knowledge and experience of other designers. Let us continue with the design patterns. There are four essential elements of design patterns and that were defined by the Gang of Four in their patterns book. So the four essential elements of design patterns are: number one, a name that is a meaningful reference to the pattern that is required. Number two, a description of the problem area that explains when the pattern may be applied. Number three, a solution description of the parts of the design solution, their relationships, their responsibilities. This is not a concrete design description, it is a template for a design solution that can be instantiated in different ways. This is often expressed graphically and shows the relationships between the objects and object classes in the solution. Number four, a statement of the consequences, the results and the trade-offs of applying the pattern. This can help designers understand whether or not a pattern can be used in a particular situation. To illustrate pattern description, observer pattern is used, which is taken from the book by Gamma et al. This is shown below. Pattern name observer. Description is: separates the display of the state of an object from the object itself and allows alternative displays to be provided. When the object state changes, all displays are automatically notified and updated to reflect the change. So this is the description. The problem description. In many situations, you have to provide multiple displays of the state information such as graphical display and tabular display. Not all of these may be known when the information is specified. All alternative presentations should support interaction, and when the state is changed, all displays must be updated. This pattern may be used in all situations where more than one display format for state information is required and where it is not necessary for the object that maintains the state information to know about the specific display formats used. So this is problem description. Solution description. This involves two abstract objects, subject and observer, and two concrete objects, concrete subject and concrete object, which inherit the attributes of the abstract objects. So here we have in the figure 8.2 subject and observer. and in that we have the concrete subject and concrete observer. Concrete subject will be inheriting from the subject, and the concrete observer will be inheriting from the observer. So concrete subject and concrete object which inherit the attributes of the related abstract object. So there are two abstract objects here, subject and observer. So just now we saw in the figure. So these are the abstract objects, subject and the observer. Fine. And these are the concrete objects, concrete subject and concrete observer, both will be inheriting from these abstract classes. Fine. These abstract objects include general operations that are applicable in all situations. So here we have some operations, and those operations will be inherited to these concrete objects, concrete subject and concrete observer. The state to be displayed is maintained in concrete subject which inherits operations from subject, allowing it to add and remove observers. That is, each observer corresponds to a display, and to issue a notification when the state has changed. The concrete observer maintains a copy of the state of the concrete subject and implements update interface of the observer that allows these copies to be kept in the step. The concrete observer automatically displays the state and reflects changes whenever the state is updated. Here we have UML model of the pattern in the figure 1.2 here, just now we saw. So this is actually the UML model of the observer pattern we say. So here we have two abstract objects, subject and observer, and just now we studied, and it has got the operations attach and detach observer and notify. And here we have the update operation, and these have to be implemented or those have to be derived. So the concrete subject and concrete observer correspondingly they will be inheriting, and they have got their operations such as get state and update operations, and the subject state and observer state attributes. Fine. So this indicates a graphical representation which are normally used to illustrate object classes in patterns. So this is a diagram that is depicting the observer pattern with the help of object classes and their relationships. These supplement the pattern description and add detail to the solution description. Fine. So the consequences here is the subject only knows the abstract observer and does not know the details of the concrete class. Yes, the subject knows the abstract observer and does not know the details of the concrete class. The subject knows the observer. Fine. Therefore, there is a minimal coupling between these objects. Here we find minimum coupling between these objects. Because of this lack of knowledge, the optimization that enhance display performance are impractical. Changes to the subject may cause a set of linked updates to observers to be generated, and some of which may not be necessary. So figure 1.1 shows two graphical representation of the same data set. So here we have the subject class where we have got some set of data A, B, C, D. This is the data set, and there is observer 1 and observer 2, and through the observer 1 we can display this data in this format. The same data, A is a 40%, you can say, B 25% portion, C is a 15, and D is a 20, like that. And this is one way of displaying the same data set, and the same data set can be displayed through the bar chart or bar graph. A B C D display, that is A is 40, B is 25, C is 15, and D is 20. This way we can display. So we can say in multiple ways we can display the same set of data. And whenever if you make any modification here in the data set, okay, for example, the best example for this is, take for example the Excel sheet or Excel cell contents. So some data we're writing here 40 and say 25, 15 and 20, and these are for the timing A, B, C, D data. And whenever you make some modification, say for example B data, instead of 25 you make it say some 50, like that. So B if you make is as 50, so then the associated charts or displays get updated. So to that data there is a bar graph connected, and there is a pie chart also connected, and when you make any modification here in this data, automatically there will be updation in the charts. So this is what we call as an observer. The data, the subject we have, and the observer, two of the observers are observing this data, and they are connected to the displays. The observers are the displays in fact. So when any modification is done in the cell, so automatically that will be displayed in the corresponding charts. So this is a observer pattern, we say. This kind of pattern we call as an observer pattern. This is a one way of pattern designing. So the best example is Excel cell changes and the corresponding updation in the multiple displays. Fine. So this is just now we studied in connection with the problem and problem description, where we had a subject and observer class, and we have the concrete subject and the concrete observer inheriting the features from observer and subject. These both are the abstract classes, and here these are the concrete objects which will be implementing the abstract methods. And through the object we can say attach and detach the observer, and notify also in case for all the objects in observers. For updating we can notify also to the observer, and this is we can use it. These are the comments, just a comment. What exactly this get state, you want to get the state of the concrete object, concrete subject, return the subject state. And suppose if you want to update the state, observer state, it has changed. Just now we have seen the changes made in the Excel sheet, so that we can update it. To use patterns in your design, you need to you need to recognize that any design problem you are facing may have an associated pattern that can be applied. Examples of such problems documented in the Gang of Four's original pattern book, that includes tell several objects that the state of some other object has changed. So that is what we call as an observer pattern, just now we have studied. So we have got several such patterns, and among several, a few have been mentioned here. So one kind of pattern is observer pattern, and the second one is tidy up the interfaces to a number of related objects that have been developed incrementally. So that kind of pattern we call as a facade pattern. Okay, so here the interfaces between the number of related objects, interfaces. So such kind of pattern is a facet pattern. And here provide a standard way of accessing elements in a collection irrespective of how that collection is implemented. That we call as a iterator pattern. So we have a collection of objects, and using any of the looping, say for loop, while loop, using that loop we can display the objects, we can display their state, we can display their contents, we can display the objects using a looping strategy. Okay, so that we call as a iterator pattern. And next is allow for the possibility of extending the functionality of an existing class at runtime, that is decorator pattern. So there is one class and another class you want to extend. You can build up another class based on this. At runtime you are doing it. In that case we call it a decorator pattern. So notes, pattern support high level concept reuse. So for in the sense, for once a problem is identified and once the pattern is identified what for that particular problem, and the same pattern can be used for many such similar problems. So that is the biggest advantage of the patterns. So that way patterns can be reused. So once you design a pattern for a problem, and you can reuse that pattern to solve common problems. Fine, that is the main theme, main idea behind this lecture, to understand that is a design pattern. Patterns are a great idea, but you need experience of software design to use them effectively. You have to recognize situations where a pattern can be applied. So over a certain period of time, by spending some effort, okay, you can design a pattern, and that pattern can be used to solve certain kinds of problems. So and these patterns can be reused. Let's have the summary of the covered topics in today's class. So we studied design patterns, so belongs to the L2 level as per the Bloom's taxonomy. You can also connect the design pattern to the applying level also, that is at L3 level also, if there is a new design pattern is available, or you are designing a new pattern for a new kinds of problems. In that case you are applying the learned knowledge of design patterns, and yes, of course you are designing a new pattern, and in that case it will be at the level 3. So basically design pattern is a description of the problem and the essence of its solution, so that the solution may be reused in different settings. Patterns have made a huge impact on object-oriented software design. Patterns are a way of reusing the knowledge and experience of other designers. Four essential elements of design patterns are, say, the name to be given, that forms a meaningful reference, a name, and a description of the problem area, description of problem area, and a solution description. And the fourth one is the consequences, that is the statement of the consequences. So these topics help the students to understand the design patterns. So the book prescribed for this is Ian Somerville, Software Engineering, 9th edition. Appears in Education 2012, Chapter 7, Design and Implementation, page numbers 191 to 195. Okay, students, just go through these topics. If you get any notes, please do ask me. Thank you.